Alright, 5.2, integrals involving trig and natural log. It's a lot of stuff. In fact, you've probably already seen it. I'm going to post the notes, my hard copy notes. I don't usually do that because I think it's much more helpful for you to take notes. But this time, given the length and the circumstances of not being in school, whatever, I'm going to post them, so you may want to print those out and just follow along with them and make extra notes or whatever as you go. Maybe that'll be more helpful today. Again, notes are kind of long, but that's because there are no new notes for Tuesday. So, yeah, just be warned ahead of time. All right, we'll start with information you already know, or you should already know, the integral of sine of u du. So going backwards from sine, the antiderivative of sine. It means it came from cosine, and it would have been negative, because the derivative of cosine is negative sine, plus c. Antiderivative of cosine, cosine of u du. So going backwards from cosine would be sine. Derivative of sine is cosine, so I don't need the plus or minus thing. Well, it's plus, and then plus c. Those two we already know, should already know. Next two, we don't know, and I'll show you a way to figure them out later. For now, I'm just going to give them to you. A little bit later in this video, I'll show you how to reason through them and arrive at them, so you can kind of decide on your own, do I want to reason through it, or do I just want to straight memorize it? I'll let you pick what you think when we get there. So for now, negative natural log of the absolute value of cosine of u plus c. I know you're like, how am I going to remember that? But there's a way to reason through it, and we'll get there. Antiderivative integral of cotangent of u du. Well, the relationships between these continue. So if the antiderivative of tangent goes to cosine, then it maybe makes sense that the antiderivative of cotangent goes to natural log of sine. And if this one's negative, this one's positive. You have to know all these, so the stars don't mean you got to know it, because you got to know everything. But that gets one star because you can figure those out, and I'll show you how in a moment. The next two, the antiderivative of secant. There is a way to derive this and arrive at the answer, but it's probably not one you want to do. This is probably a memorize situation. You know, usually we'd rather you understand than memorize, but there's some facts you just got to know, and so this would be one of those things that you need to put on a note card, or whatever method you use to memorize stuff, you need to do it with this one. The antiderivative of secant is natural log absolute value secant of u plus tangent of u plus c. Maybe that seems weird, maybe that seems odd. If you take the derivative of this, you get there. So you could prove to yourself that it works even if you weren't sure where it came from. And then lastly, the antiderivative of cosecant of u du. Well, again, secant, cosecant, there's going to be some similarities here. Secant's going to become cosecant. Tangent's going to become cotangent. And the sign's going to be different. So there's, I'll kind of zoom out. Sine, cosine, tangent, cotangent, secant, cosecant. The antiderivative of each of them. You already know two of them because those are the easy ones. We've done those already. These two are a little bit tricky. The last two, a lot tricky. I don't know what you have to do. You just got to know those. So that's the rules for trig. Now let's talk about the rule for natural log. Integration with natural log. Lots of u substitution in this section. I'll show you what I mean in a minute. Let me I guess remind you that the derivative of natural log of, I don't have pink, so I'll go red triangle, is 1 over the red triangle times the derivative of the red triangle. So if I go backwards from that, the antiderivative of, we're going to use du and u. Well, this is the undoing this gets us back to natural log of the absolute value of u plus c. So that's another one you have to know, but it's one that we should already know because we know this rule, we're supposed to know this rule, and so this is just the backwards form of this rule. It's the same rule, one's just looking at it going forwards, the other one's looking at it going backwards. And we've mentioned this before, the better you can drive forward, the easier it is to drive backwards. It's still tricky to drive backwards, but the more experience you have going forward, it's a little easier going backwards. Whether you're driving a car or whether you're taking derivatives. If you've taken enough derivatives of this one to be able to do it forward, then going backwards is tricky, and you got to go slow, but you should be able to do it. All right, let's do some examples. The integral of x squared over 3 minus x cubed dx. Well, again, u substitution, u substitution, u substitution. Some of you did great on that section of the test. Others of you, well, we'll keep doing it, so you've got to figure it out sooner or later. We want to pick u so that du shows up, or something close to du shows up. So if I pick u to be the bottom with an x cubed, then du would be the top with the x squared, or something close to an x squared. So I'm going to let u be 3 minus x squared, or excuse me, 3 minus x cubed. That's a 3. Then du would be negative 3x squared, which is close to what we have up here. Remember, we can fix things that are off by a constant. Not too bad. And so this top part is du, and we have 1 over u du. And we have to get to the point where we recognize that. You just have to get to the point where du over u, or 1 over u du, you know that that's natural log. You just have to get where you know what that is. That's the natural log of the absolute value of u plus c. And then we got to put u back in there. Natural log of 3 minus x cubed plus c. So u du, where u is the bottom. We're used to making u the bottom, but sometimes it's a square root, sometimes it was a whatever. It's still many of the same rules for u and du, but now natural log is going to show up. Number 2, the antiderivative, or the integral of 4 over 3 minus 6x dx. Well, again, I got to pick u, and I'm looking, I think if I again make u be the bottom, then du would be negative 6 dx, which I don't really have, but I can play with constants to make it work. So I think the easiest thing to do for this one is to pull the 4 out front, and then put a negative 6 on that, and a negative 1/6 out front. So I just move the 4 because he's kind of in the way, put in a negative 6 to make it work, and then a negative 1/6 out front. You can reduce these. You don't have to reduce these. You can safe stop type stuff here. So negative 4/6 du over u. So negative 2/3 natural log of the absolute value of u plus c. Negative 2/3 natural log of 3 minus 6x plus c. Again, you've got to get to the point where you recognize that du over u becomes natural log. A little bit of a side note here: if you're thinking about the power rule, here's when you'll know that you're on the wrong path. The power rule is increase the power by 1 and divide by the new power. Well, you can't divide by 0, so if you start thinking power rule, hopefully you realize pretty quick that doesn't work. Instead, it's natural log of the absolute value of u. So again, you've got to be able to recognize that quickly so that you can pick your u and du correctly and get to a right answer. Number 3. Integral of cotangent of 3x dx. Integral of cotangent. Okay, that was in that second set. 3 there is a little bit goofy, so I'm going to let u be 3x, du would be 3dx. So 3 1/3 cotangent of u du. Let's see, that was natural log of sine. If you have it memorized. If you don't have it memorized, here's the figure it out method. Is when you get tangent or cotangent in there, you can rewrite cotangent as cosine over sine. And then if you think about doing a u substitution, although you're already in u, so you'd have to do a second u substitution, which should mean like a v substitution or something else. But if you let u be the top, no, you want to let u be the bottom. If u is sine, then du is cosine, and you would be doing the integral of 1 over u du, which is natural log of u, which was sine. That's the figure it out way. That's really the way I do it, because I don't have this one memorized really well, because I know I can figure it out. I can rewrite it as cosine over sine, and then I know it's natural log something, and then I can figure it out from there. If you have it straight memorized, then you're just going to know that it's natural log of the absolute value of sine of u plus c. So 1/3 natural log, absolute value, sine of 3x plus c. So that was one that had the tangent cotangent thing in it. Again, you can do the figure it out method, or you can do the straight memorize method. I prefer the figure it out method because that's one less thing I have to memorize. Antiderivative of cosine of x over 2 plus sine of x dx. Again, u substitution, u substitution, u substitution. I want to pick u so that du shows up. Well, I know the derivative of sine is cosine, so if I let u be the entire denominator, then du is just going to be the numerator, and so this one's actually kind of easy compared to the other ones if you pick the right u and du. So natural log of u, which is 2 plus sine x plus c. Nothing wrong with that as an answer. I will say that sometimes if they don't need the absolute value bars, CalcChat or the back of the book will drop them. Sine of x is always between -1 and 1, so if I add 2 to it, it's always positive. So they're not needed, or the absolute value bars aren't needed. It wouldn't be wrong on a free response question, but on a multiple choice question, they would probably switch those to parentheses because they're not needed. because this is always positive. It's not something you have to worry about. And on a multiple choice test, they wouldn't put both answers because they're both correct. They would just give them a more simplified answer. Number 5. 1 over cosine squared x times tangent of x, all in the denominator. Well, now we have to really be careful about u and du. And let's see, derivative of cosine is sine, negative sine. That doesn't really help. Derivative of tangent is secant squared. That actually does help if we're really paying attention, because 1 over cosine squared is secant squared. So a little bit of trig identity work there. And so if u is the denominator, du is the numerator. And so another one of these, let's see, the top is du, the bottom is u. Now it's easy to recognize in this section because they're all the same, so they're all natural logs. But again, you've got to be able to start recognizing when that happens, it's natural log of u, natural log of the absolute value of u, plus c. Two more examples, almost there. Integral of natural log of x to the 4th over x dx. Well, again, you've got to know your derivatives well enough so that you can identify who should be u so that du shows up. Again, a lot of times we take what's on the inside, like if there's nested functions, we let u be the inside function. Du would then be 1 over x dx, which actually works out pretty well because that's exactly what that is. Natural log of x was u, so this is u to the 4th du. Well, that's supposed to be an easy one. That's a power rule. Increase the power by 1, divide by the new power, plus c. So 1/5 natural log of x to the 5th plus c. I haven't done on any of these the checking thing where you take a derivative and see if you get back to where you started from, but this would be an easy one to check. If we took the derivative of this thing, it would be 5 times 1/5 natural log of x to the 4th, chain rule, times 1 over x. And that's where we started. So a lot of times it's easy to check these to make sure you got them correct. All right, last one. And this one's yucky. I'll make sure I do a homework example similar to this one in the next video. Integral of x cubed minus 6x minus 20, all divided by x plus 5. Well, you can mess around with the u stuff here, and you're not going to get anywhere. So I'll play with it a little bit. Sometimes we let u be the bottom, but then du would just be dx, so that doesn't really get us anywhere. I guess you could go the really long way around on this, where you set x equal to u minus 5 and then plug that in up here, and then you'd have to cube it, and that would be a mess, so I don't want to do that. If you let u be the top stuff, so looks like, okay, that's a reasonable guess. 3x squared minus 6, but that's not what's in the bottom, and we don't want du in the bottom anyway, so that's not getting us anywhere. So here's the rule. If the top degree is greater than or equal to the bottom degree, right? Degree meaning highest power, so this is a 3 degree versus first degree. Then you have to divide. And you can long divide if you want to. It's probably easier to synthetic divide. I know it's on video, but I heard you moaning all the way over here about, wait a minute, synthetic division, what's that look like? When we take the coefficients, remember there's a 0 in there because there's an x squared that's left out of the order. And I want to divide by x plus 5, which means that minus 5 goes there. How you remember that is if x plus 5 is a factor, that means x equals negative 5 is the root. So we'll divide by, or divide with, negative 5. Bring down the 1, multiply, add, multiply, add. 19 times 5, 20 times 5 is 100, so 19 times 5 is 5 less than that, the negative. Negative 115. And then you got to think, well, what in the world does that mean? Well, I started with a, excuse me, I started with an x cubed, that means I'm down to an x squared, minus 5x, plus 19, minus the 115 divided by x plus 5, what we started with. So if I rewrite this problem, I want the antiderivative of x squared minus 5x plus 19. Like, all of that's easy though, right? That's power rule, power rule, power rule. And this one's not as easy. Let's, how do we want to do this? Let's knock these out first. That would be x cubed over 3 minus 5x squared over 2 plus 19x minus, I'm going to move the 115 out front, integral of 1 over x plus 5 dx. Well, I could use a u substitution if I want to, but that's almost not even worth it. It becomes du over u. So minus 115 natural log x plus 5. Plus c. What a lovely problem that is. But again, the big point of that one is if the top degree is bigger than the bottom degree, you have to synthetic divide. And then don't forget to integrate your answer, because all you're doing by synthetic dividing is rewriting. You're doing algebra first, and then don't forget to do the calculus. This is a place where some people stop here like, oh, there's my answer. Like, no, that's what you now need to integrate. All right, the assignment is page 334, and it's odd. All of this, odd applies to all of this. I'm trying to write it so it says that. 5 to 27, 35 to 45, 49 to 55, odd applies to all of that. Next video, I will answer what I think are the common questions from those. And I guess the good news is the next video, which is I'm answering questions, will be the last video, and it's all this stuff is for Monday and Tuesday. So spend your time however you need to. I don't know if I'll see you Tuesday or if it's still iced over, snowed under, who knows what's going on. But give those a try. Oh yeah, the section is 5.2, so if you're going to Calc Chat to see those answers and to see the steps worked out, you would need to know that it's section 5.2. All right, I hope you guys are having a great day. I hope it's a fun day right now, and this is just a little bit extra thrown in to make it fun, maybe. And then maybe we'll get tomorrow as well. So stay safe, stay warm, and I will see you sooner rather than later, I hope. Good luck.